Why there's so much? You print so much. This one. Why you print so much?
There's 24 of you. What? Okay, so the very first thing we learn is the first formula if your degree is measured in okay, so if you have a diagram, a circle, okay, we learn that there are different names for different parts. So of course, this circle, the whole thing, just talking about its length, is circumference. Okay, and then if you cut a portion of it out, this tiny section here is called your minor sector. Okay, then the big part here is called your major sector. So all this we have learned last year already. I'm doing a recap so that we can do the worksheet later. So this is called
That's what I said.
major sector. Too many, huh? Yeah, us. Because the absentees are not absentees, they are obey, right? Okay, so remember, sector must be cut from center of circle. Okay, it's like a slice of pizza that is cut from the middle of the circle. Why? Okay, it's not any page, I'm just doing a recap. You want to copy down somewhere so that you can use it for your WA1 revision. Okay, next, how do I actually calculate the area? So this piece over here, if let's say this angle is, I don't know, 60 degree. Okay, in order to calculate the area, I need to find out what fraction of it, okay, is this sector. So it's 60 degree out of 360. So this is the fraction of the sector. So even if I don't tell you the formula, you should know this is by fraction, by proportion. And then you multiply by the area of the circle, which is pi r squared. So this is the area of circle. So this formula will help you to calculate area of sector. So whatever this angle is, you can calculate the area of that piece. So what if I'm interested in the green piece? How can I calculate the major sector? 360? So you should use this angle instead. So same formula, but this time round we use 300 degree. So instead of 60, it's 300 out of 360. Also multiply by pi r squared.
So must we put minus 60?
No need, you can straight away calculate. Okay, so whether it's minor or major sector, it's the same formula. It is theta over 360 times pi r squared. So this is the formula for area of sector. One formula to remember. Okay, so this is what we have learned in 9.1. Or rather 9.2. 9.1 was arc length. Okay, arc length, what's the difference? Arc length means we are talking about the circumference part. That means I'm interested in finding what is the length of this string.
So what does tangent mean?
Tangent means a straight line that only touch one point on the circle. So if let's say this is the point, then my tangent line is this one, only touch that point on the circle. This line is called a tangent line. Okay, so circle property, we'll talk about this later. Okay, so the second formula we will learn, if I'm interested in only calculating the length of this arc, this is called a arc length. Okay, Then we will use the same thing by proportion, right? I know this is 60 degree out of 360 degree. But instead of calculating the fraction of the area, we find the fraction of the circumference. Okay, because the whole circle, right? This whole length, if I cut this portion up, it will unroll into a straight line, right? So this whole circle has the length of 2 pi r. This is a formula of circumference, or in primary school, you remember it's pi d, right? So this whole circle, if I wrap it around with a string, this string has the length of 2 pi r. This string has the length of 2 pi r. But now I only want a segment of the string. This one only, this part only. So instead of the full circle 2 pi r, I want to know what is the length of this part only. So it's 60 degree out of 360 degree of the whole circle. I only want this part only, this part only. I'm finding this tiny length here. This tiny length here. The length over here, this one. So instead of the whole circle, at 60 degree, I only want that part of the arc. What is the length of that arc? So 2 pi r instead of pi r square. Because I'm not interested in the area, I want the length only. So which tells me that the arc length formula is theta over 360 times 2 pi r. So this is the second formula that we have learned last year. This is 9.2, this is 9.1. Okay? So if they want length, use the 2 pi r formula. If they want area, use the pi r square formula. Okay? It's just circumference or circle only. Okay, so these are the two formula. Then the third part, we learned that actually there's another way you can measure angle. When your angle is measured in radians, they say let's use another unit to measure the angle. Okay, so when it's measured in radian, they say convert. Every pi radians represents 180 degree. Just like when I tell you 1 meter is 100 cm, this is just how it is. The person who created 1 meter say 1 meter means 100 cm. So the person who created radian say pi radians means 180 degree. So this is a conversion unit. So if we look at the formula here, these two formula that we have learned. Okay, these two formula that we have learned. So nice to be young, huh? The sec 1, you see? So happy. Okay, so these two formula that we have learned, in 9.3, they say you can use another measurement. So they say when you see 2 pi, change to 100, when you see 180 degree, you change to 2 pi. Change to pi. Ayo, what's wrong with me? When it's 360 degree, it is 2 pi. So this one times 2, times 2. So when you see 360 degree, let's change it to 2 pi. They ask you to convert. Okay, when you see 360 degree, let's change it to 2 pi. Because they want you to convert the unit. Just like when you see 100 cm, change to 1 meter. Now they say if you see 360 degree, change to 2 pi. Okay, we convert. So when you convert, you realize that the formula changed a little bit. The formula changed a little bit. Now arc length formula can be simplified to be... We use 2 pi. We change to 2 pi. What? Sorry? No. Sometimes the question give the angle in radians. When they give you in radians, you have to use this formula. Yeah. So when you check, right, actually, to find arc length, the formula has simplified to r times theta. That's all. Okay? And then another formula here, if we simplify this, we cancel off the pi. Then you realize that area of sector change to r square theta over 2. This is the formula for area of sector. So 9.3 has two new formula. But actually it's the same thing, just that it's measured in radians. So 9.3 has two new formula. But don't worry about memorizing these two formula because it's given in the formula page. These two formula is given. The first two is not given. So this one is not given. This one is not given. So if you want to use, you need to memorize. But it's not difficult to remember. Okay, so just remember that. So this is 9.3. Okay, 9.3 we learned this. Then the last one, 9.4. They realized that there's another way we can divide the circle. So they say if you join these 2 points up, this special blue line has a special name. They call it your chord. Not your musical chord, but rather the chord that divides the circle into 2 segments. So this divides the circle into a small segment here called the minor segment, the blue part. This part here is called minor segment. Okay, the minor segment. Yes, chord is a straight line that joins 2 points on the circle. So diameter is also a chord, the longest chord in your circle. Okay, then this big part is your major segment. The big one, the big segment. Okay? So I want you to see that actually, right, the minor segment is minor sector take away triangle. Can you see that? This piece? Let me take it out for you. Can you see is this part? Take away the triangle. Is this minor segment? Take away the triangle. That's why you are left with the blue part.
How do you find the blue part?
So you must use your formula to help you. So can you see? Minor sector, just now we learned the formula already, right? We learned that if this is theta over 360 times pi r square, right? We learned just now that the minor sector, this whole piece, can be found by this formula.
How do you find the triangle?
The triangle, we use half AB sine C. You remember? This is A, this is B, followed by the angle in between. Your area of triangle formula. So how to find area of this triangle? It will be half times A times B times sine theta.
So did you give the side number?
Yes,
Must give, then cannot.
they will give. If they don't give you, you can't do. Okay, later I will show you examples of how to use this. So to find segment, you know this formula from 9.1. You know this formula from trigo. Then you can find the blue piece. Okay? So what if they want you to find the yellow one, the big one? Then can you see there is actually the big piece? This one, major sector. Okay, plus the triangle. So to find major segment, you have to add the major sector to the triangle. So major sector to the triangle. So is the formula different? No, because major sector also this formula, and then you add up to the triangle. That's all. So is there a new formula here? Don't have. You just need to know when you add, when you subtract. So this is 9.4. So this is the entire chapter 9 we learned last year. So the formulas you need to know are just these few. 1, 2, 3, 4, 5. Okay, so I'm going to write these 5 formulas on the board. Later when we do the work together, we can use it. Okay, these are the 5 formulas that you need for WA1 also. Survival mode, ah. Ayo, why so? Teacher write so hard. You want to make her angry, is it? Please, ah. The teacher is due in March when Mrs. Hall will come back. You all don't make her upset, ah. Then I don't know how to help you already. Not enough POA teacher. Okay, so arc length formula, when theta is in degrees, it's theta over 360 times arc length times what? 2 pi r. Okay, but when it's sector area, then it's theta over 360 times pi r squared. That's the only difference. Area is this, length is this. Okay, when theta is in radians, okay, remember 2 pi is 360 degree or pi is 180 degree. This is the unit of conversion. So this formula becomes just r theta. And this formula becomes r squared theta divided by 2. Okay? It's the same formula, just that you change the 360 to 2 pi and simplify, become like that. Okay, last formula is segment area. So remember, segment area got 2 types, minor or major. So remember, if this is your circle, this piece here is the minor. The remaining one is the major. This big one is the major. So minor easy. Use theta over 360 times 2 pi r square. Right? This slice of pizza, take away the triangle. So minus half r square sine theta. This is take away the triangle. This piece, take away the triangle. Okay? That's why what you're finding is just this slice, the small one. Okay? But major is the big slice.
Outside the triangle. Outside the triangle.
At the triangle. So is this big one plus the piece of triangle. So you get this slice.
You need to include the triangle.
Need. So major segment is the whole red thing. So the formula is the same thing, but you add. So this whole chapter 9 has these 6 formulas that you can remember. Okay, but these 2, don't worry, is given in the formula sheet on the first page. This one is given. You need to memorize. The rest you need to memorize. Okay, so this is question 9. Okay, a lot of things to load in because you need the formula before I can review the question with you. What? Why the brain die already? So fast. Okay, let's see if we have a arc length question that we can do first. Okay, then maybe let's not review 10 now. Sheet I gave you. Can we go to the worksheet I gave you? Inside consists of 4 big questions. Okay, in this paper that I gave you, right? It comprises of questions, 4 questions I took from last year's O-level as well as 2024 O-level from these 2 chapters. So let's try to do it together. Yes, it will be tested definitely. Okay, let's look at this part only. Let's look at this part first. Let's ignore the circle property question. Let's zoom in to question 1C. Okay, sit up straight, Kiran. Okay, they say the radius of the circle is 8.7. So let's go and write it down. This is 8.7. 8.7. So radius. There? The radius of the circle. Okay, then they say, can you calculate the area of the shaded sector OAC? So OAC, the shaded one is this one. Oh, because that one is circle property, I haven't reviewed that. So let's go into this first. Tested. I will go through that later after I review, because if not, you forget already. Okay, so this one is what they want me to find. So if we go to the board, which formula do we use? Where got tangent? Which formula can I use if I want sector area? This one, right? Okay, then you will ask me, this one or this one? There's 2 sector area formula. Which one I use? Use the upstairs one because the angle there is degree. So we use the degree formula. So this is the formula I'm using. But in order for me to find the fraction of this piece, I need this angle. If not, I can't do, right? So how to find this angle first?
180 minus 150 minus 23. Then you get the answer. Then the answer minus 360.
Okay, so what, correct, this year he changed already. Okay, we want to find AOC first. So part C, I write here so everybody can see. Angle AOC, I will use 180, take away the 223 degree. Because those 2 lines are radius, so you have an isosceles triangle. So you get this. They never ask for the reason, no need to write. Okay? Okay, but I just write as a recap. Okay? So once you know that this angle here is 134, you can find the black angle here, this one. So reflex means the outside of angle AOC. We use 360, take away 134. So this is angle at a point. Okay, so now I know this is 226. So once you know the angle, you can find the fraction that is shaded. So using the formula, area of sector OAC, we use this formula. Okay, this is the formula, so just plug and play. Theta here is 226. Use the big one. And then radius, they already tell you is 8.7. Pi is the calculator pi. Then you just give me your answer in 3SF. Then that's 3 marks. Good question. I don't have calculator. You calculator? Don't have. Then you come to math class, no calculator. Next week, Monday to Wednesday. Next lesson quiz. 149.277. So 149 lah. cm square. Okay? This is the 5SF. Okay, if you are unsure how many significant figure to round off, always give me more than 3. If you give me more than 3, I give you full credit. Anything less than 3, then I minus mark. Okay? 9, if today we can do 10, then I'll quiz 10 also. Okay, but if not, 9 only. Okay? So this is part C. I haven't do A and B because that's circle property. We'll do that in a bit if we have time. Can? So this is 2025, last year's O-level question. So if you are tested on arc length sector area, this was what happened last year in O-level. This is the question that appears.
Teacher, can use the sector A r square tangent over 2.
Sector A r square theta over 2.
Yeah.
Only if you change the theta to radian.
Radian.
Then you can use that formula.
What is radian?
Means, okay, so how to use that formula? So now, Silesh is suggesting, can I use this formula instead? You can if you change the angle to radian. So now the angle, we know that 180 degree is pi radians. So 1 degree is pi over 180. Then the angle here is 226. So you must first change this to radians first. So once you change this to radian already, then you can use this formula. So you can use this formula, you will get the same answer. But your radian, you use this answer here. Okay, so you must convert before you can use that formula. So it's good for you to know both. Okay, it's good for you to know both. Okay, let's look at the next question that is relevant to arc length. Flip, next page. Question 2. This also appeared last year.
I just so hot today.
Yeah, wake up. Find out. Let's go to the word away. Okay, this one. So you look at the picture, it says the shaded area represents the area cleaned by a windscreen wiper. Find the area of the shaded region. So what do you think you can do? What is the big piece? What is this big piece called?
Quarter circle.
Quarter. Is it quarter?
Sector.
It's a sector, but it's not quarter because it's 96 degree. More than a quarter. So this big piece I can find. I can find the area of the big sector first. Okay? So area of the big sector, we use the formula on the board. It's theta over 360 times pi r square. Why use theta over 360? Is because this is in degree. When it is in degree, use the degree formula. So to find it, very simple. I already got the angle. It's 96. I already got the radius of the big sector, which is 90.
But need to do 124.
Need to what?
124.
No need. This is the big sector. The whole thing is 90. So this is the big one. I haven't looked at the small one.
Oh, cannot like take 60.
No, you cannot anyhow. No, cannot. $96. Okay, so this is the big sector. Then now, we are also interested in finding the small sector, this one. So this small piece, you can find using the same formula. Just that the radius is different. Okay, so angle is the same, still 96. Okay, but your radius is now, what's the radius of the small piece? What's the radius of the small piece? 24. Okay, so how to find this? How do you find this piece? The big one minus the small one. You use calculator. I never bring a calculator. Okay, so if you do it diligently, look at the question carefully, it is just these few formulas on the board. Okay, nothing more, nothing less. Got snack break? No, my snack break is the lesson before me. Can. Six three zero 3.292. Correct or not?
482.548.
Huh? 482?
Round for small one.
Oh no, both minus.
That minus 6303.292.
So what's the answer?
6303.
So 3SF 6300. Okay, but if you give me this, you are correct also. More accurate, I will give you full credit also. 3SF, full credit. More than 3SF, I also give you full credit. Anything less, don't have. Okay, so you can be more accurate but cannot be less accurate. Okay, so if you see sector question in your WA, it should roughly look like this. Can't go any more fancier than this already.
This is question 3, area of sector.
No. Question 3 is circle property. Let's go question 4. My lesson end at what time?
210.
Oh, still got time. I wanted to give you all this directly as quiz, but I know I will end up marking a lot of interesting blanks. So, I will give you all another quiz next lesson so that I can see your real ability. Show me your power, please. This year must be showing me your real ability already. Don't hide it. Done? Okay. Okay, let's look at question 4. So you look at the shape, look very fancy, but they tell you that M is the midpoint of AB, N is the midpoint of CD, AB is equals to CD. They tell you a lot of info, right? Then they say the radius of the circle is 4. So go and put that in. 180 degree is pi radian. So all these radius is 4 cm. They tell you first. Okay, then they say angle COD. This one is 1.8 radians. Now the angle is in radians already. So you must be careful what they give you. Then they say, can you find the length of the major arc AB? So major arc means the big one. This is the major arc. This is the minor arc. The blue one is the minor one.
R theta.
So this one is major arc. Yes, the formula is R theta. Because, okay, this is the dividing line. You want the big piece. So if we are looking at the circumference of the circle, I want the big one instead of the small one. Okay, when they use the word major means they want the big piece.
This was just 1.8 over 2 pi. Just find the small one.
No need to convert. So remember, this angle that they give you is in radians. So when you want to find out length, just use the radian formula. So don't overcomplicate matter. Major arc AB is r times theta. So what is the radius of this major arc?
1.8.
What's the radius?
1.8.
Where got 1.8? What's the radius?
Where is it?
So radius is 4. What is the angle?
1.8.
Oh, wait.
Radian.
I don't know the angle yet, right? I need the angle. I only know this piece. We don't have all the info. COD. Correct. Okay, you see okay, you need one other layer of understanding. This is also 1.8. It's a congruent triangle. Both of them are exactly the same. Okay, so this is also a 1.8. So if I use the formula r times theta, let's say this is my r, and I multiply by theta, I'm finding the minor one.
Yeah, say that is not.
No, this one is not the answer yet. Okay, so I'm finding this piece. So how do I find the black one? What is my theta? What is the theta externally? This one.
2 pi.
More than that. 2 pi is the whole circle.
2 pi minus 1. 2 pi minus 1.8.
Good. It's stylish. Got hope. 2 pi is the whole circle, right? The whole circle. Take away this red part. Take away this red part. So the green angle is this part, which is 2 pi minus 1.8. So this is the angle, the green angle that I have that will help me find the black arc. So the formula is just this. Then press calculator only and then you get the answer. That's all. So it's a very simple formula, but you must plug in the right value. Okay? So when it's arc, look at the angle. This is in radians. Then you must use radian formula. So these are the crucial parts.
Yeah, question.
What?
Can find the entire circle area with radian.
Entire circle?
Yeah, area.
For what?
Just radius.
Can. Just use that. R square theta over 2. You find the sector. But if you want to find area, just by R square lah. Don't even need angle what. The R is 4. What's the answer? 17.93. Okay, remember length you can 3SF, but if you give me more than 3SF, it's correct also. So don't worry about that. Okay, so just use this formula because the angle is in radians. No need to go and use the degree formula. Okay, the last question is the tricky one. It's the tougher type of question. Okay? Let's look at the last question together. This one. Okay, I'm going to separate the question. So maybe you can be less confused if you can see them as separate circles.
Make them make two triangles. Like make
Can.
triangle.
Can.
Then 14 and 80 degrees.
Yeah.
15 and 30 degrees.
Yes, correct. Oh, not 15 and 30, that one wrong. But the 40 one is correct. Okay, so let's just focus on this circle first. My mission is to find the area of the shaded part. But you never learn how to find eclipse or anything, right? You never learn how to find this. You only learn sector, arc length, and segment. So must be either one of these. So in this case, you know that you can find partially first. So maybe I want to find what is the area of this segment first, this part. Hari Raya.
Sing our school song, man.
Is it school song?
Yeah.
I sound like Hari Raya song. Okay, so if we would just focus finding the area of segment, this one, first. Then if this is 40 degree, this is isosceles triangle, this is also 40. So you can write this as 40 degree. Okay, and to help yourself, maybe you can label this as, I don't know, S, P, Q, R. Maybe we put a T here. Then maybe this is a U. So you can label them properly. So you can write angle SPT is 40 degree times 2. Okay, the reason is because of isosceles triangle. Okay, so once you know that that angle is 40 degree, finding area of segment is on the board. But of course, it is not given. You have to memorize them, right?
How do you find the triangle?
Half AB sine C. Remember that? Oh, but they gave us the radius. Must read the question. Sometimes they don't put on the diagram. So this is 5. This is 5. 140? No, that one is 40. I draw the angle. Okay? So area of segment formula, I just copy down what is on the board first. This is a minor segment, so you take away the triangle, not add. Major, then you add. Minor is the small one. So everything I just plug and play. The angle is 80 degree. Radius is 5. Okay, your calculator make sure is in DEG mode. Calculator must be in degree mode. If not, it will give you a very weird answer. So that's it for the first part. You can find the area of that shaded part first.
So for the area of triangle, you do 4 caso, 10 caso,
10 caso,
2 caso.
2 caso. Yeah.
You do that.
Actually, it's this. Remember, you all learned in AMF, not AMF, EMF trigo before, the letter V and the angle in between. So the formula is half times AB times sine of the angle between them. So this one is what you all have learned in trigo last year. So this is area of any triangle. Okay, area of any triangle. Okay, so once you have found that part, I leave it to you to go and write the value there. A square equals to B square plus C square minus 2BC cosine A. Cosine formula, of course got cosine. Okay, next part is I want to look at the second circle now because I haven't found this other part. No, because they are lopsided. They are not symmetrical, so you cannot times 2. You need to find the other segment. But in order to find that, you need this part.
They say 15 cannot because it's not radius.
Yeah. So this one, remember this is the sector I want. But that 15 degree is not in the triangle. So can you all remember circle property? How to find this angle? Angle at center is what angle at circumference? Can you all still remember? Do you all remember? It's twice. So this is the angle at circumference. This is the angle at circumference, which is 15. So the angle at center is 30 because it's 15 degree times 2. If you still remember your circle properties, angle at center is double angle at circumference. Do you all remember I told you all before? Forget. Got 4 types. So one is like that. This one is double of this. Then we also have the F1 flag. If this one is double, this one is X. So what we have in this question is the F1 flag. If you can see.
What F1 flag?
There you see the flag or not? Yeah, the flag. But in a different orientation. Okay, then we also had this. If you can still remember, we say there's many types, right? The rocket. And then the very last part is like the kite.
She did.
So remember, angle at center, twice angle at circumference, we have 4 types. This is one of it. But I will recap chapter 10, don't worry. Now you forget, I understand. Okay? So we know that this is 30. Let's do a repeat question. Let's call this T, right? So angle SQT here is 30 times 2. Because this should also be 30 because it's an isosceles triangle. Because I need the angle at center. I need the sector angle. Isosceles triangle. If this part here is 30, this part here should also be 30 because it's an isosceles triangle. Because of this property, angle at center equal to angle at circumference. This one is a circle property. That's why it's important. They like to lump the properties together. Okay? So anyway, now using this, can you see? They repeat the question, but using 2 different circles. It's the same concept. So to find the shaded segment there, I will repeat the formula. So to find this area of shaded segment is also theta over 360 times pi r square minus half r square sine theta. This is the formula I'm using. But the angle is different. The radius is also different because they say the radius of the bigger circle is 8 cm. So this thing here is 8. Okay, so just take note of the difference. And then everything else is the same. 60. Radius is 8. But other than that, everything else is the same. Okay, so you have an answer part A. So to find the shaded area, you just basically add up the 2. Okay, so now you understand why it's 5 marks. 2 each. Final answer 1 mark. So this is what came out in 2024 O-Level, which is your holiday homework. You should have seen this question.
Yeah, I did.
If you didn't see, means you haven't do your homework well. Okay, so final answer for the shaded region, it is just answer A plus answer B. Okay, so this is last year's chapter 9. What's the answer? For those who are calculating. Hey, calculate.
I know I can't.
Don't dream. Okay, your math file last year, what color was it?
Yellow.
Math file?
Yellow.
5.143.
Green.
Green?
Yes.
No.
So small, the answer.
Around 5.143 is area of segment. The small
Yeah.
one.
Oh, this one.
The first
Yeah,
one.
the first one.
Yes.
Then the big one.
Big one, I don't.
I don't have to. Where's the answer?
This one. Find this. Calculate for me.
60 over 360 is 60. This so is 6.
The half.
6 times pi 8 squared minus half 8 squared.
You know, like
47.7.
47.
37.7.
More DP.
1, 2,
Like that. Okay, so final answer.
plus
32.85.
865.
No, 885.
855.
855.
8. Yeah.
Okay, so if you give me 3 SF, you should have 32.9. Okay, or if you can give me more, it's fine as well. So I'm just showing you the rigor of this chapter with the 6 formulas on the board. They can test you mixing the question with circle properties. Okay? Okay, it's at 90 degree to your chord and it cuts it into 2 halves, 2 equal halves. That's why it's called bisector. So this is one property you need to know, rarely tested in O level. Okay, second one, perpendicular from center. So if you have a line that is from the center that is perpendicular to the chord, it will basically cut it into half. That's what it's saying. Okay, so this is the second one. Third one, if you have 2 chords that are of equal length, meaning this one and this one, if they are equal in length, they are equal distance away from the center. So this is equal chords equidistant from center. So these 3 are the chord properties. Okay, then these are the angle properties. We have a tangent line. Tangent is always perpendicular to radius. This is one that you need to remember. The second one is this one. Just now I told you all about this, right? Angle at center is always double the angle at circumference. So this one is not so good because they don't show you all types. Just now I show you all the flag. This one is double. I also show you all the butterfly. The butterfly. Right, center, oops. Center is always double of the circumference. And then the very last one is the kite. So if this is the circumference, then the center is double of it. So there's 4 types. Okay, I don't know the time. Okay, so there's 4 types for number 2, 4 different cases. And then we also have this, the butterfly. The real butterfly where all 4 points are on the circumference. The same part of the wing is the same angle. So these 2 same, these 2 same. Then the very last 2, number 4, is if you have a quadrilateral, the 2 opposite angle add up to 180. Okay? And then if you have a semicircle, and then you form a right angle triangle, this is always 90 degree. The very last one is if you have 2 tangent lines and they meet at the external point, these 2 triangles are congruent, meaning this is the same, this is the same, this angle is the same, and these 2 angles are the same. So go back and revise this. Next lesson, expect a quiz on chapter 9, which will be taken from this. Okay, and then we will review chapter 10. Can I? Okay, back up. What lesson is it?
Chinese.
Chinese.
This
Okay. Because you are going there already. Right?
one.
Yeah.
And Thai Siu and 大白兔.
I already have one. I haven't even eat here.
Wow.
I'll eat today, okay? I'll eat today. Okay, thank you, class. Your leg like don't know what. Okay, go for your Chinese. Do well in mother tongue.